Hey all, and welcome back to another long-awaited video. Today I'm building a 3D printed, fully functional train that I used to catch as a kid going to and from high school. There's a strong sense of nostalgia every time I look at this awesome model, and being able to build something like this just shows how far along the technology we have available has come over the past few years. This project will rely heavily on a 3D printer, namely the Anycubic Photon Mono M5S, which was sent to me from Anycubic, who are sponsoring this video. I'll talk more about the printer later in the video. The base model I'm working with is free to download from Thingiverse. It was created by JMO's Trainos, so if you want to download the model and build one of these yourself, you can. I'll have a link in the description. The model itself is great, but I had a few additions I wanted to add specifically on the trucks and the base. Tinkercad is perfect for this, and it's perfect for simple geometric shapes and details. The train itself is from the 90s and still in service today, so finding reference photos to work from is pretty easy. I also wanted to work on the base in order to make it a little easier to connect and disconnect from the top half of the model as well as add details. I won't walk you through the entire process of creating detail and redesigning the base. It's a long process and mostly involves trial and error and test fitting and resizing many times until I find a design that meets the needs I'm after. Once done, we can download the model and send it over to the Anycubic Photon Workshop. This is Photon Workshop version 3, which is an updated version, with lots of improvements over the previous version. Once imported, the Photon Workshop will warn you if there are any errors, and it can fix them automatically if necessary. The model is orientated so that it fits within the build area. This model is quite long, so it had to be angled quite a lot to get it to fit. Supports can be added automatically. However, depending on the model, you may need to make slight changes to the structure of the supports. What's great about this program is that if you hover the mouse over the name of the item, it will show you an image of what you're adjusting, which makes it so much easier to visualize the changes and what effect they'll have. While the automatic supports are a good starting point, you'll most likely need to either add or remove supports for specific areas. But don't worry, it's very easy to do and doesn't take too much time. Next, the print settings are set. These will vary depending on the resin you're using. I'm using some Anycubic high-speed resin, so the exposure time is quite low, which is great for models that take up a lot of the build area. If you're not sure about settings, Anycubic have a great list of resin types and settings for their entire range of printers. Now the model is sliced. Depending on the complexity of the model, it can take a few minutes. Then it's saved onto the USB and taken to the printer for printing. The Anycubic Photon Mono 5S is the latest printer from Anycubic. It's quite a large printer, which makes it perfect for a big and highly detailed project like this. The screen is 12K with a horizontal resolution of 19 microns, which gives it extremely clear and defined edge detail. My favourite feature is the auto leveling. The build plate locks onto the Z-axis very securely, and a mechanical sensor on the cantilever arm detects the fit between the printing platform and the floating leveling module and automatically adjusts it based on the detection results. It's a great printer not only for seasoned 3D modelers, but also for the beginner modeler as well. When coupled with the new Photon Workshop, you'll have no problems getting even the more complex 3D models to print first time. And even if you do run into a potential problem with the model, the printer can detect a range of issues and let you know when a fault in the printer has been detected. Make sure to check the link in the description to take advantage of the early bird special. The printer comes with everything you need to get started. And most importantly, it comes with a good solid spatula for removing the prints from the build plate. As soon as the printer is powered up, it will run a few startup tests. For the first print, we need to add the screen protector, which means the Z-axis will need to be raised. The printer comes with a good set of instructions on how to apply the screen protector. I recommend adding the screen protector as soon as the protective film is removed to avoid dust getting onto the screen. It's a bit of a challenge getting it lined up, but there's a lot of overhang so you can get away without it being perfect. I ended up getting a bit of dust on the corner, but it's easy enough to remove with the screen cleaning kit that is provided with the printer. As you can see, I didn't get it perfect. A bit of trimming was needed. Once the top protective film is removed, it's almost ready to go. The raised locating pins are great for lining up the resin vat. They are also great when the vat is sitting on the table. It means the bottom of the FEP film isn't rubbing on the surface of the table, scratching it. For this project, I'm using a couple of different resins. I'll be using some of the Anycubic high-speed resin, along with some of the standard grey resin from Sunlu, and finally I'll be using some tough resin. I'll have a link in the description where you can buy some of the Sunlu new resin, as well as a link to the Anycubic Photon Mono 5S. For the body and the base, I'm using high-speed resin. For large models, this stuff is great because it means you're not waiting 20 hours for a model to finish printing. The entire volume is able to be printed in about 3.5 hours. To get the most out of the high-speed resin, you need to use the Photon Workshop, along with the high-speed resin and the high-speed release film that comes with the M5S. It's also important to hollow the model so the suction forces as the model is lifted are minimal, and set the layer height to 0.1 millimeters. With all that combined, you can get a print speed of 105 millimeters per hour. If you want more detail, you'll need to set the layer height to something a little bit smaller, while sacrificing some print speed, but even then it's still a fast printer regardless. You can see how quick each layer is being printed. I also noticed the high-speed resin is much less viscous compared to the tough resins. Now the model is finished printing, it's time to post-process. It's important to wear gloves for this. As part of the post-process, I do a vat clean to pick up any small bits of resin that possibly remain stuck to the FEP film. The model is carefully removed from the build plate. It's then dunked into a container of 99% isopropyl alcohol. Because the high-speed resin is so thin, it cleans off really well. I let it sit in the alcohol for about 10 minutes and lightly agitate the alcohol to remove any uncured resin. Once washed, I spritz the model with some more alcohol and then use the air from the airbrush to dry the model. The alcohol evaporates really fast, so it doesn't take long to dry. This particular piece was cured with the support still connected. That way it reduces the amount of warping as the last bits of resin are curing. If you don't have a curing light, you can always use the sun. After about 15 or 20 minutes, the resin that was cured as part of the vat cleaning process will start to lift on its own, making it easier to remove. If I'm going to be printing in another day or two, I usually leave the vat with the resin still inside in a dark cupboard so that it's ready to go for the next print. The build plate is so much easier to clean when there's no leveling screws to work around. A word of caution, the airflow from the bottom of the printer gets quite hot while it's printing. Hot enough to warp my cutting mat, so make sure it's on a surface that can withstand the hot air when it's in use. When the model is post-cured with support still on, it will make them a little harder to remove. More care is needed to remove the supports close to the edge or on thin sections so you don't crack or chip the visible areas. For supports on areas that are not as important, they can be torn out. Just ensure you wear safety glasses to avoid small shards of resin ending up in your eye. With most 3D printed parts, there will be some amount of tidy up and sanding. Resin sands very easily and often doesn't need all that much sanding. As for the internal area, only the bottom sections of the walls need sanding for the shell supports I created that will get glued in later. Supports that are removed before curing tend to come away a lot easier and generally require less tidy up and sanding afterwards. You can see how easily they peel away from the supports. The same post-process steps are done for these parts as well. To fit the shell supports, I first screw them into the base. I created a small hole in the shell support so that a tiny self-tapping Phillips head screw would fit. I bought a whole bunch of these tiny screws. Unfortunately, I don't have a specific measurement for these, except that they are really small. Once fitted, the base is slid into position on the shell, and then the first support position is marked. A drop of superglue is added on each side above the marks. Then the base is repositioned and the walls pressed firmly so the support is permanently attached to the shell. To remove the base, the screws are unscrewed and the base is carefully pulled away. The screwdriver may be needed to pry away the shell from the base if any glue oozed out into the wrong spot. Only a small drop of glue is needed. These steps are repeated right along the model until all the shell supports are permanently fixed into position. For the extra parts like bogies and pantograph, I decided to print them in tough resin. I was extremely surprised by the tough resin. It's partially flexible and very strong. While fragile parts will still break, these last much longer than standard resin parts. I threw some of the parts with quite intricate detail pretty firmly on the table, and they just bounce right back with almost no damage. The front is also printed in tough resin. When attaching separate parts, I use super glue. Now we're almost ready for some paint, but of course the model needs a clean to remove all that resin dust, and a thorough dry. A small droplet of water can ruin a good paint job. Tamiya spray paints work fantastic with 3D printed resin. The surface primers are great and go on very smoothly. The main colour of the train is silver. Tamiya mica silver is perfect for the finish I'm after. And just like the primer, it goes on very smoothly and evenly. The base and bogies got sprayed a Tamiya NATO black. Now for the windows. To be honest, I was going to laser cut them. However, I hadn't used my laser cutter for a while, and soon came to realise it needs a new CO2 laser tube, so I guess I'll be hand cutting the windows. I created an SVG template using Tinkercad and loaded it into Photoshop. I did a similar thing for the decals I'll be showing later. The file can then be printed as a template to cut out. I used a 1mm thick sheet of acetate for the windows. The template is glued onto the acetate with its protective film still attached. Then each window is carefully cut out with some sharp scissors. The corners can be lightly sanded to create the rounded corners. Then a quick test fit on each window to make sure they fit properly. On the prototype, the front is a light blue-grey colour, so to model that more accurately, I masked it and sprayed the front with Vallejo pale grey blue. While that was drying, I created a set of decals. I found a great website that has images of all the different liveries over the years. Perfect to recreate the decals. Once I had the images saved, I brought them into Photoshop. That way I could scale it down to the right size and cut out the part of the image I wanted to turn into the decal. It's a bit of a tedious process, but this will make all of the difference on the model when it's done. I'm so grateful someone has taken the time to create an archive of liveries that is itself a massive undertaking. Once the decal set is done, they can be printed. I found using photo paper settings on ultra quality seems to work the best. Depending on the printer, if it's inkjet, you'll need to seal the decal paper. Otherwise, the ink will run in the decal setting solution. Tamiya Clear seems to work pretty well for this. Just make sure to give them about 24 hours to dry after applying the Tamiya Clear. The model will also need a coat of clear so the decals turn out perfectly. Once again using Tamiya Clear. I did run into an issue on the front. After applying the clear, it started to crack the top layer of paint. I suspect it was because I didn't give the acrylic paint enough time to cure. I've used Tamiya clear over a Vallejo acrylic in the past without any problems. Luckily, after about 12 hours, the cracks smoothed out somewhat, but they are still slightly visible. Adding decals is pretty straightforward. A good sharp knife is needed when cutting them out. Once they are cut out, I use Humbrol Decal Fix to apply them to the model. Only a small puddle is needed, and the decal is left floating atop the puddle while it's slowly released from the backing paper. I also put a layer of decal fix on the area I'm going to place the decal. This helps keep the surface slippery, so I can slide the decal around on the surface while I get it into position. Excess is gently soaked up with the brush once the decal is in its final position. It's starting to look good with the decals on, and the same is done for the front decals as well. Now for the motor. This is a Tenshodo motor with a 28mm wheelbase and 10.5mm wheels. I'll be powering it with a Lokesound 5 decoder. The motor as it comes is DC only, so to convert it to DCC, we need to remove a small tab. But to do that, we also need to dismantle the base. It's easy enough to do, just one screw and the base plate can be pulled away. The tabs are removed with the Dremel. Before reassembling it, I also add a drop of lubrication for good measure. To reassemble, the base is pressed back on and the screw attached. As for wiring, the Lokesound decoders come with a good set of instructions. I got the 8-pin interface, which I plan to use, however in the end I just cut the 8-pin plug off and wired it directly to the decoder. I won't go into detail on the wiring, because it's all listed in the instructions of the decoder booklet. However, for the Tenshodo motor, you'll see I'm soldering some wires onto the sides of the bogie. These are the track voltage pickups, and the 2 tabs on top are for the motor. I've created a screw bolt setup in order to connect the bogie to the locomotive. The screw, bolt and red paper shims all come supplied with the Tenshodo motor. I designed the model so that it would fit with all those specific parts. The little 3D printed clips prevent it from detaching from the chassis. It's pretty well an identical setup for the rear bogie as well. If you find the wheels aren't turning freely, you can use something like axle bearing reamers from DCC Concepts to get it turning freely. Now it's just a matter of attaching each of the wires to the appropriate spot. As I progress through the wiring, I periodically do a test run, just to make sure it's all working after each step and I haven't made any major mistakes. I also wired up the main headlights using some 1.8mm LEDs, as well as the speaker and speaker box assembly, which is just superglued together, and then the entire box is superglued onto the base. Again, it's tested, and so far so good. With the wiring complete, and once the decals have had 24 hours to dry, I can give the model a final clear coat. I'm using semi-gloss. Given the train is metallic, it should have some sort of a reflection, which is why I'm going with a semi-gloss. It's a good compromise. Again, once the clear coat is dry, I come in and add some final paint detail, like the black across the front of the front windows. As for the windows, I use some Micromark PSA glue. The glue goes on white, and after about 5 or 10 minutes, it will go clear. Once clear, I press the windows into position. Doing my best to avoid fingerprints, which is why I'm wearing the glove. It's a bit fiddly, but once they are in, it does look quite good. Before closing it up, I decided at the last minute to add some figures. It wasn't really planned, and the next model I build would have this in mind, but for the time being, just having a few figures should sell the effect. When closing the shell, I need to be careful not to pinch the wires. I end up using a piece of tape just to hold the wires while placing the shell on top. Lastly, it's just a matter of adding these screws and it's done. It's truly amazing what we can build today with 3D printers, and the Anycubic Photon Mono M5S is a perfect example of just how detailed and accurate 3D printing has become. It wasn't all that long ago when doing something like this was reserved for the extremely patient and talented scratch builders, but now even the average builder can create some amazing models. Thanks again to Anycubic for sponsoring the video. The M5S is an amazing printer, and I'll be using it in many future videos. Cheers, and thanks for watching.